Okay, so let's go ahead and prove the derivative of f of x is equal to cosine x today. So the claim is that if f of x is equal to cosine x, f prime of x is equal to negative sine of x. Okay? Okay, so let's go ahead and proceed in our attempt to prove this. Using, of course, the definition of the derivative as a limit. That's how we do it around here. So f prime of x, okay, by definition of the derivative is equal to the limit as h trends to 0 of cosine of x plus h, okay, minus cosine of x all over h. Okay. All right, now I am going to use the expansion formula, the identity for the cosine of a sum, which I've proven in another video, so feel free to access that if you so desire. I will establish it right here, though. If you have the cosine of a sum or difference, okay, that's going to give us the cosine of A times the cosine of B minus or plus, right? So if it's a sum, it's a difference in the expansion. If it's a difference, it's a sum in the expansion. Sine A, sine B. Okay, so let's get a big box around that. Very important identity. That again, we do have a proof available for if the viewer is interested in seeing that. Okay, so we'll be using that here today. This is going to be equal to the limit as h trends to 0. Okay, all right, using our expansion, we're going to have the cosine of x times the cosine of h minus sine of x sine of h minus, of course, cosine x. And then all of that, of course, over h. Okay, there we go. All right, well, we can certainly factor a cosine x out of the first and third terms, so let's go ahead and do that. So we're going to have the limit as h goes to 0 of cosine of x, and then the other factor will be the binomial cosine of h minus 1, right? First and third terms. Let's not forget, of course, this middle term, minus sine x sine h. That's going to be there still. And, of course, that's all going to be divided by h. Okay? Now, yeah, good. A very important formula, or a very important property, is that the limit of a difference is equal to the difference of limits. Okay, and this can be proven using real analysis, and we might at some point provide a proof for that. I don't know if there's going to be too much demand for that kind of proof, but certainly if the viewer requests it, we will do that. But the limit properties are rather intuitive when you really think about them. And they are exactly as we would want them to be. Limit of a difference is the same thing as a difference of limits. Limit of a sum is the same thing as a sum of limits. Limit of a product is the same thing as the product of limits. Limit of a quotient of limits, just as we would want, right? Limit of a function is the same thing as the function of a limit of a function, and so on and so forth. All right, so we will be taking advantage of this property today. So we're going to have as follows here, the limit as h trends to 0. Okay, we're going to have cosine of x times the quantity cosine h minus 1, all of that over h, okay, minus, okay, the limit as h trends to 0 of sine x sine h over h. Okay, it's going ahead and breaking that up there. And now it's should be clear that the limit here is dependent on h, not x. So this factor of cosine x can actually come out. And likewise over here, this limit's dependent on h, not x. So this factor of sine x can come out of the limit. Let's go ahead and do that. Okay, so it's going to give us cosine x times the limit as h trends to 0 of cosine h minus 1 over h, okay, minus sine of x, taking that out now, times the limit as h trends to 0 of sine of h over h. Okay, good. Now a couple of very important limits that are typically presented in a introductory single variable calculus class are as follows. We're going to have the limit as h trends to 0 of cosine of h minus 1 over h. This is equal to 0. Okay, and I will be providing a geometric proof for not only this one, but for this as well in a future video. Okay, but I'm assuming that the viewer has at least some rough familiarity with these two limits, given that you can't really get through any single variable introductory calculus course without seeing these two. Essentially, when you study L'Hopital's rule, or when you study any limit that goes beyond the ordinary, you're gonna see these two here. So hopefully the viewer is comfortable with my presenting these and incorporating the veracity thereof into the proof here. Okay. Again, we'll make sure to make a future video in which I'll present a geometric, or shall I say diagrammatical, explanation for why these are the case. All right, so if the limit as h goes to 0 of cosine h minus 1 over h is 0, then, well, that term goes away. Okay, cosine x times 0 is just 0. And the limit as h goes to 0 of sine of h over h is 1, then we're done. This is going to be negative sine of x times 1, which of course is negative sine of x. So there we go. There we go. Hopefully you enjoyed that video and you found it to be instructive. It's important to understand not only how mathematics works, but why mathematics works. We always appreciate your comments, questions, concerns, and recommendations for future content. Have a great rest of your day, and we will see you in the next video.